Hello, I'd like to talk about improving the injection molding process with the Inject-EX. The patented Inject-EX system is an improved injection molding technology that is comprised of a non-reciprocating, which means stationary, helical plasticating screw housed within a cylinder that is coupled to a plunger head assembly, motor, and drive housing that reciprocates within a pressure vessel designed to convey, melt, homogenize, and inject molten polymeric material more precisely and efficiently along one axis. Comprises the unitary Inject-EX unit. The Inject-EX design addresses the three major deficiencies of the 75-year-old reciprocating screw design. Number one is viscosity variation due to the fact that every pellet experiences a different resonance time and shear heat, and it gets worse when the shot size gets large. Number two, constant pressure flow changes across the shutoff plane of the non-return valve. And number three, variation of the quantity of the polymer displaced due to inconsistent non-return valve closure. So what we're trying to do here is to replace the reciprocating screw and V-line plunger technology with the Inject-EX. So if we take a look at an Inject-EX model, this is a design for high-speed application where we have a little longer L over D screw. We start the design with an advanced posi-mount screw. The design is based on what polymer we're trying to process in the application. That screw sits inside an inner barrel. On the distal end of that is our automatic shutoff plunger head. We have melt temperature sensors, and then on the output side of that, we have our mini shutoff nozzle tip, which stabilizes the melt pool and prevents stringing and drooling. That whole assembly sits inside a pressure vessel. And back here we have a feed housing that is attached to the inner barrel. On the inside diameter of the inner barrel is our rifle grooves. And this is good for improved solids conveying. This is a technique that has been used in extrusion for many years, but somehow has never been installed in injection machines. And then we have a powerful hydraulic torque motor, high-speed motor. Here we're showing Inject-EX for LSR. The full hydraulic unit. If you notice here, we don't have a drive screw. We don't need a screw. So this unit is compact. It's powerful, very high injection pressures and speeds. We have an inner barrel. The material is fed through the feed housing into the inner barrel and through our plunger head technology. And on the end of there, we have some specific shutoff nozzle based on the application. And this is the our version of LSR. And we have also designed and fabricated Inject-EX for large area pellet-fed 3D printing. We've been in the 3D printing field for many years. The Inject-EX offers the ability to not only print, but to inject a very precise amount of polymer when needed. And one of the last concepts that we have is a Inject-EX for recycling, where we actually use a star feeder and a vented barrel technology that we're very familiar with, and install a melt filter for a circular economy. So you see the side view of the Inject-EX. We use this pull-in cylinder to move the assembly in and out on our saddle and base system. That is very strong, powerful, very unique design. If you look at a top view of the same assembly, you can see how this works. This screw would start to rotate. When the screw rotates, it conveys, melts, pumps material through our plunger head that has a poppet and a seat and Belleville spring washers that require force to open and flow to open. As that occurs, pumps through the plunger head, it displaces volume in that cylinder within the pressure vessel there. The assembly backs up to a set position. When the assembly is in that position, then that's where we can stabilize the melt pool in a fashion that has not been done yet so far in the industry, cannot be done with a reciprocating screw, in that we can measure the melt pressure and then densify the melt pressure by either moving this in or out and or keeping this in position and rotating the screw. So every pellet traverses along the axis of this screw through our plunger head into the pressure vessel and displaces volume. Top view of a small diameter LSR application. You can see where we have the hydraulic cylinder that is directly in line that moves the plunger technology that we have up here. This is a very small unit. It's like a 12 millimeter plunger for micro molding. A larger version of the Inject-EX for LSR is shown above. This is where we can feed through the feed housing, pump the material through the inner barrel, through our plunger head, displaces volume, and we would back up to perform a shot. Can inject in this fashion. So the unique components of the Inject-EX system comprises a posi-melt screw. We've been designing posi-melt screws for over 20 years. We have some very advanced models with our barrier and XLA mixer and or XLA mixer, or for very high filled materials, we would use our multi-purpose or standard posi-melt design. We have our plunger head. The plunger head, we have proven this for many, many years with our mini shuts, automatic shut-off nozzle tips. Material will flow through the center, push the poppet off of its seat, allowing the material to flow through. And as soon as the assembly, or as soon as the flow stops, then the poppet will come back and shut off instantaneously. We have high pressure seals, 2 of them actually for each plunger head. So that it prevents any leakage between the plunger head and the pressure vessel. We install our mini shut nozzle tips on all thermoplastic models. A version of this is also usable for LSR. It requires force to open and flow through the center, and then as soon as the flow stops, it shuts instantaneously. Our melt sensors are used to measure real-time melt temperature as well as work. And we measure the work by employing our Melt IQ system that measures the temperature over time and put a specific heat number into the equation, and we can generate power factors and viscosity rise integrals. So it's the area underneath the curve that's formed here. It's a very powerful model. We can determine whether we make good or bad parts by measuring the work that it takes to inject the polymer into the tool. At the present time, we can sell LSR or thermoplastic injection molding machine models. We have 10 to 70 ton vertical or horizontal versions available for sale. Give us a call. We can see, we can put a package together for you. I appreciate your time.